You're able to see my screen share, right? Yeah. Shivank, yes?
Yeah.
Okay, cool. Okay, so I'll just paste it here. Why is it coming this way? Fine. Okay. Yeah, so AMC10 topics, right? So we'll get started from the top. Classification. You guys know there's real numbers that we start off, right? Real numbers is represented with R. Actually, technically, before real numbers, there's complex numbers, which is not needed, but you can just know, right? So complex numbers are which involve like square root of -1, for example, right? An example would be 3 plus 4i. If some of you might have seen something like this. So it has a real component and an imaginary component. Okay, so the real part in this case is 3 and the imaginary part is 4i. Okay, so we'll fall in the real part for most of our discussion. So anything that can be represented on a number line is a real number. So √2 is real, minus pi is real, 0 is real, right? 3 by √17 is also real, right? And of course, the number 5 is real. The number -7 by 2 is also real. So anything that's on the real axis is real. And then from this, we have rational and non-rational. So whenever we put a dash or a bar, it means it's the complement, right? So rational numbers are anything that can be represented as a fraction, p by q. So for example, -7 by 23 is a rational number. And 5 by 1 is also a rational number, right? So anything that can be expressed as p by q, where p and q are integers and q should not be equal to 0, right? So for example, I can write 3√2 by √8. Okay, this is still rational because I can simplify √2 and √8, right? √8 is 2√2. So I can simplify this as 3 by 2. So in the given form, it might not be an integer by integer, but as long as I can simplify it and get to an integer by integer, it still counts as rational. Okay, so that's the fractional definition of a rational number. Is my recording still on? Yeah, good. Okay, and then there is a decimal representation of a rational number, decimal definition of a rational number. So anything that can be represented as a terminating decimal, for example, 7328, it ends. That's a rational number because I can write it as 7328 by 10,000. And anything that repeats, right? So for example, it need not repeat right afterwards, right after the decimal. The repeating can start after like this, 569, 569. So it can be represented as 0.24 569 bar, right? And then how do we make sure it can be written as a fraction? The standard trick is move it by so many decimals so that the repetition starts right after the decimal point. So in this case, I'll multiply by 100. So that will bring it to 24.569 bar. Okay, and then if I multiply this by a further 1,000, then I get 24,569.569 bar. I multiply by a further 1,000 so that the repetition of the digits starts again once more. So this is 100,000x, right? And then I can subtract this minus this, whatever. I'm not going to do it, but whatever, 99,900, I guess, x equal to whatever the subtraction of these two is, 24,545, right? And then you can bring this here and write it as a fraction. So terminating decimals as well as repeating decimals are both rational, and non-terminating decimals would be like, for example, pi approximation 141592654. These are the first of 10 decimals or so, but you don't see any pattern repeating. Just because the 4 came here, the next one need not be 1, right? So there's no pattern repetition at all. Then it's an irrational number. Okay, and then we have integers, which are a subset of rational numbers. Okay, so integers, which are represented as Z. Okay, and non-integers, which are Z dash, right, which is not integers. So within integers, we have negative integers, which is represented as Z minus. We have 0, which is a family by itself. And then we have positive integers, which is Z plus. Okay, so and Z plus is nothing but the set of natural numbers. So starting from 1, 2, 3, and so on, right? That's the set of counting numbers, or now known as natural numbers. And if you include 0 along with this, that's called the whole numbers. So the collection of 0 and Z plus is the whole numbers. Okay. Yeah. So yeah, and just familiarize yourself with the letters that is used. R for real, that's very clear. N for naturals, that's also very clear. Z is a sort of a little different one. So Z is integers and Q is for rationals. Okay. The next one is should be completely flexible between fractions, percent, ratios, decimals, all of this, right? You should be able to switch back and forth. For example, if someone asks what percent of 0.08% is 3/4 of what is it, fraction, percent, decimals, right? 3/4 of 0.0102, right? Then can just literally translate this to a mathematical problem, right? So what is nothing but X per cent. So percent is per 100, right? Per is division, cent is 100. So X upon 100. Of is nothing but multiplication sign. 0.08 is just a number. I'll repeat 0.08. There's a percent again here. So I'll divide by 100. Is just equal signs. 3/4 is just a number. Of is multiplication, and 0.02 is just a number. So once you write out like this, there's no confusion. Should I multiply by 100? Should I divide by 100? All of this, right? Cent is 100. Percent is divide by 100. That's it, right? And then 0.02 is 0.02. 0.02 is 2%. 0.08% is different from 0.08. We all know, right? 0.08 is 8%. 0.08% is 0.08 by 100, right? Which is a much smaller fraction. Okay, so that you should be familiar. Arithmetic progression and geometric progression. That's very, very important, especially geometric progression. So let's recap the main fundas in arithmetic and geometric progression. So arithmetic progression, it starts with a constant number. So it starts with some starting number, sorry, let's say 2. And then uniformly you have increments. The uniform increments or difference is 3 in this case, right? And then typically you want to find the nth term. So Tn or Un or sometimes An, all of these are used to represent the nth term. So nth term is, you have A, that's the starting point, plus, so for example, in this case, to reach 14, which is the 5th term, I had to take 4 hops. I had to take the number of hops was 4 hops, which is 1 less than 5, because I'm reaching the 5th term, and each hop is of size 3, right? So same thing. Yes, you start with A. The number of hops is 1 less than the term number I'm seeking. So n minus 1 hops if I'm reaching the nth term, and each hop is of size D. So it's A plus n minus 1 times D. That's the nth term. And then the other thing is the sum of n terms. The sum of n terms in arithmetic progression is very easy to remember. It's just n times the average of the very first and the very last term. So I'll just say F plus L by 2 so that it's easy. F stands for the first term, N stands for the last term, right? So n times, the first term typically is A itself, and the last term, as we just derived, is A plus n minus 1 times D. So in textbooks, if you see, the numerator would be written as 2A plus n minus 1 times D. That's a little difficult to intuit. If you split it as A plus n minus 1 times D, it's very clear. It's the first term plus the last term divided by 2. It's the average of the first and last times the number of terms. Or in other words, the average of the first and the last is the average of the entire sequence itself. Because whatever sequence of numbers you have, arithmetic, geometric, this, that, anything, right? What the definition of average is the total sum by the total number of elements. So S suffix n, S has to be the product of n and the average anyway. So, and this average in arithmetic progression alone happens to be just the average of the very first and the very last. So you don't, in a way, you don't care about the intermediate numbers. Generally, to do average, you need all the numbers and then divide by n, right? For arithmetic progression alone, to find the average, you just need the first term and the last term. That's it. The average of the first. That's because the differences are all uniform, so they are compensating from both ends. Okay, so that's arithmetic progression. Geometric progression. geometric progression, same idea. You start with some number and then you have multiplicative hops, right? Instead of additive hops. So you start with A and the ratio or the hop is R, let's say. So AR square, AR cubed, AR power 4, and so on, right? So again, same thing. To reach the nth term, you have to, so in this case, what did we do? We started with 2 and you had 1, 2, 3, 4 hops to reach the 5th term. And each hop is a multiplicative hop of 3, right? So it's 2 times 3 power 4, or more generally, A times R power n minus 1 to reach the nth term. Okay, and then the sum of n terms in a geometric progression is A times, you can derive it, I'm not going to derive it, A times R power n minus 1, okay, by R minus 1. Okay, note the difference here, it's R power n minus 1 to find the nth term. When you find the sum of n terms, it's R power n cos minus 1, right, separately outside, right? And you can also write it as A times 1 minus R power n by 1 minus R, depending on R is a smaller number than 1 or bigger number than 1, you can use one or the other. Both are, maybe both will come to be positive or both will come to be negative, right? So depending on convenience, you can decide which one to use, but both are same, right? And then this particularly is useful, right, when we talk about sum till infinite terms. In geometric progression alone, we have the sum till infinite terms. If R in magnitude is less than 1, right? So why does that happen? So if you have a fraction like 3 by 5, or even a negative fraction like minus 9 by 10, right? If you raise it to a large number, let's say 10,000, right? Then this almost approaches 0, right? And I'll make this odd, right? So it'll be negative, minus 9 by 10 power an odd number, but still it's approximately 0 only, right? It'll alternate between minus and plus, but 0.9, when you keep multiplying by itself like 10,000 times, you will see, you can try it on a calculator also, practically goes to 0, right? When a fraction gets multiplied so many times. And therefore, as n tends to infinity, right? You write tends to in math using this arrow, then we can say R power n tends to 0. If this condition is true. So if R is less than 1 in magnitude, R power n tends to 0, which means S infinity therefore becomes, so S infinity becomes A into 1 minus 0 upon 1 minus R. So it just becomes A by 1 minus R. So this is the typical thing that we would use. For example, if you're calculating the sum of 1 plus half plus 1/4, the classic ant problem, some of you might have seen, right? Ant travels 1 meter first day, half meter second day, 1/4 meter the next day. If it lives for 100 years, how much will it travel? 100 years is like infinity practically. So it will travel 1 by 1 minus half, which is 2 meters. So the puzzle will go that you'll never reach the second meter at all. It'll always be a little short, but eventually, after infinite time, it'll reach. And the ratio can be negative as well. For example, let's say I have 10 rupees, and then I give half of that to, let's say, Vihan, and then day after tomorrow, he returns back 1/2 of that, and I give him 1/2 of that, and like this. Suppose we keep going, then ultimately the question can be, after a long time, how much money will I have? So it's A by 1 minus R. R is in this case negative half. Ratio is always the latter term by the former term. So it's minus 5 upon 10, right? So that will become 10 by 3 by 2. So I'll be left with approximately $7, and he'll be left with 6.66, let's say, and 3.33 approximately. Because in steady state, that's what will happen, right? So I have, yeah, okay. So 6.66 and 3.33 after a lot of transactions. Okay, so that's geometric progression and arithmetic progression. Rates and speed. So rates and speed, generally you should know the concept of, essentially speed is not just distance versus time. Speed can be with respect to anything, with flow of water. So let's say you're pouring water into a vessel at a particular speed, right? That's also speed, right? So rate of change of anything is speed. And then in the concept of rates and speed, you also have the direct proportion and indirect proportion, right? Proportional, direct or indirect. So the classic problem could be, so it can be multidimensional. Let's say there are people and jobs. So let's say 8 people can do 3 jobs okay, and they are putting effort for 6 hours per day, okay, and then they are able to complete the job in 10 days. Then the question can be 6 people doing 4 jobs, working 8 hours per day, can do it in how many days? So we can still do it, but we can learn the trick of doing it in one shot. So how we do it in one shot is, so whatever we have to solve, we just block that and keep. So in this case, X is the number of days I have to solve, and just go with some arrow mark like this. I'll tell you what this arrow mark means, right? And now we'll assess each of them. So days is what we have to calculate. Now there are 3 independent contributors: people, jobs, and hours per day. Okay. Now we'll keep, when assessing with people, we'll keep the jobs and hours per day constant. If everything else were same, if you're just looking at people and days, more people means fewer days. For a given job, for a given hours per day contribution, more people means fewer days. Therefore, the relationship is downwards. Opposite of what we put here, we put upwards, therefore it's downwards. Now, next we'll do the same thing. We'll compare days versus jobs, keeping people and hours per day same. Again, number of people is same, number of hours per day is same. More days means, is it more jobs or fewer jobs? More jobs. So you'll put this in the same direction. And then likewise, we'll keep people and jobs same. So hours per day, right? If you're able to do more hours per day, then you'll need fewer days to complete the same job with the same number of people, right? Therefore, it's reverse. So now once you have the directionality, then I can start to write. So X by 10, so I'll follow the arrow, X by 10 equal to the direction of the arrow for each of the other 3 variables. So here it's downwards. So 8 by 6 into, right? Here it is upwards. So 4 by 3 into, here it's downwards, 6 by 8. Right? I'm not going to simplify, but that's the idea. And then you can find X, whatever. In fact, in this case, it just happens. That's very nice, right? So it's 40 by 3 number of days. Right? You can quickly answer in one shot. And imagine you can include more things also. You can have some, let's say, pages printed, double-sided, single-sided. You can always make a more complicated complicated question with more such variables. In that case, this one-shot approach is a time saver, right? Rather than get confused, right? Okay. So one thing to note is the directionality will not always be this. It's not like people and number of days will always be opposite. For example, so I want to mention that. So for example, in another sitting, suppose again, I'll write the same thing. So people, days, okay. In fact, I'll just erase this. I'll give an example. So the people, I don't have to repeat the headers, but anyway, fine. Hours per day and days. Okay, so again, I'll make some example. Let's keep the same thing, 8, 3, 6, 10. Okay, and let's say this is what we have to find out. Number of jobs they can complete. And let's say this is given and this is also given, something like this. So now we'll block jobs because that's what we have to find out. Okay, now let's start to put the arrow mark direction. So I'll put it like this. Starting, I can have any choice. I can put this way or that way, but everything else is related to that. Now, suppose I compare jobs with people, right? Jobs with people, then hours per day and days is constant. So more people, we can do, with more people, you can do more jobs, correct? If hours per day and the number of days is constant, then if you're just looking at the relationship between people and jobs, the statement would read, more people can do more jobs. So the direction will go this way only. Now note the comparison between this guy and this guy. So in this instance, the jobs and people are directly proportional. Whereas in the first example, that jobs and this thing were indirectly proportional between them, right? So it's not always the arrows will be consistent. You look at what you are trying to solve for, and then with that relationship, you go. Similarly, jobs and hours per day, right? If you have to do more jobs, then you need fewer hours per day, correct? Right? So, sorry, that's not how we should state. For a given number of people, for a given number of days, okay, more jobs would require more hours per day or less number of hours per day, they'll require more hours per day. So you should frame your statement in your mind clearly, right? In other words, just ignore people and days completely. Just ask yourself, to do more jobs, do we need more hours per day or less hours per day? Don't even bring in the other factors at all. If you start to bring in, then the sentence gets complicated. More jobs means more hours per day. So here also they are, if you see, they're direct, whereas here they were indirect. Okay. Similarly, jobs and days. Okay. I won't talk about any other parameter, right? More jobs will require more days or fewer days. More jobs will require fewer days, and therefore they'll be opposite like this. And note that here in the first example, they were same direction, right? So same problem, but depending on what you're trying to solve for, the arrow directions will change. Does it make sense to everyone? Right? Kunal, you're with me completely? Apurva? Shivank? All good so far? Okay, I'll pause here. Any doubts so far, guys? I've been on a rant. Yeah.
How would more jobs require less days?
Because more people are working towards the same thing.
So jobs and days, forget everything else.
Yeah.
More jobs will require more days. More jobs will require more days. Oh, sorry. Okay. Yeah, more jobs will require more days. You're right. Absolutely right. Yeah. Maybe I said it wrong. Yeah. More jobs will require more days. That's precisely right. Yeah. Right. More jobs will require more days. Correct. You're right. Good. Okay, cool. Anyway, point is highlighted that the direction of the arrows could change. Okay, so rates and speed, and then you know how to do this kind of problems as well, right? You would have seen if two men can do a job in X number of days and 3 men. Okay, so 2 men can finish a job in 5 days. Okay, and then three women can finish the same job in, let's say, 6 days, right? 3 of them taking 6 days. And then let's say 5 men and 2 women work together, right? How long will they take, right? This is a classic question, right? So you have to deal in terms of the quantum of work that's done per day, right? So 2 men can finish, all right? So 2 men can finish the job in 5 days, which means each man is doing 2/5 of the job in a day, correct? Each man, sorry, I should take that back, right? So 2 men are doing the job in 5 days, which means each day they are getting 2/5 of the job. Sorry, guys, right? 2 men are finishing the job in 5 days. So each day they are doing 1/5 of the entire job, right? But there are 2 of them, which means each day, each man is doing half of that, which means each man per day is doing 1/10 of the job. Are we clear? Sana, are you with me?
Yes.
Okay. Similarly, 3 women can finish in 6 days. So which means in 1 day, collectively, the 3 women are able to finish 1/6 of the workload. Yeah, sorry.
It'll just become 1/18.
1/18, but the same thing, right? 1/6 times 1/3, which is 1/18. So each woman is doing 1/18 of the job per day, right? And now we can answer this question, right? So 5 men, because they are doing, each man is doing 1/10 of the job per day. In one day, how much of the work gets done? Suppose we see 5 men each doing 1/10 of the work, plus 2 women each doing 1/8 of the entire job. All right, and we can add this. So let's do this quickly. So this is 2, this is 9, 1/2 plus 1/9, which is 9 plus 2, 11/18. So they're able to do 11/18 of the entire job in 1 day, right? And then therefore we can say in 18/11 days, they'll be done with the entire job.
Approximately, I think 1.66, something like
1 point, yeah, 18/11, but you can simplify, right? Yeah. Okay, but sorry, Apurva, I don't mean to cut you. The main idea is not the simplification of the numerical value, but how to do this. Yeah, but good that you're able to spot this approximately 1.6. Yeah, good. Okay, so that's the rate. And then equalities and inequalities, that's very important. Okay, equalities, we all know, no problem there at all. inequalities, we have to be extremely careful. So the first thing you have to be careful is minus 2x plus 7 is greater than minus 3, let's say, right? So we go on simplifying, we do this minus 10, and then in the heat of the moment, we'll just divide by minus 2 and do this. This is wrong, right? When we are multiplying or dividing by a negative number, you have to flip the signage, right? So this step is wrong. It should be when we are dividing in the step, you're dividing both sides by minus 2. Therefore, it should be x is less than 5. Okay. So that's one thing to be aware of. All of us know this, but in the heat of the moment, we'll forget this, flipping the sign. More importantly, suppose we have 2x plus 1 by x minus 3. Okay. And suppose I'm asked to solve, this is less than 2. Okay. So it's very natural to write 2x plus 1 is less than 2 times x minus 3. This is wrong. Why is it wrong? Because again, the same mistake. X minus 3, we are multiplying both sides of the inequality by x minus 3. But who knows x minus 3 is positive or negative, right? So we don't even know whether we have to flip or not. At least, so it becomes question mark now. At least here it was very clear. We are dividing both sides by minus 2. Therefore, I was very clear I had to flip. Whereas in this problem, I don't know whether to flip or not. X minus 3 might be positive, in which case I don't have to flip. X minus 3 could be negative, in which case I have to flip. So unless I've solved for x, which is what the problem is, how can I even know, right? So it's like a chicken and egg problem, right? It's like hatch 22, right? Unless I know x, I won't know x minus 3. Unless I know the signage of x minus 3, I won't know whether to flip the less than, greater than or not. Right, Shivank, does this make sense? Why we are challenged in this? Shivank, yes, no?
Yeah.
Okay, then how do we approach this? We'll have to bring everything to one side. So 2x plus 1 by x minus 3 minus 2 is less than 0. Okay, all right. I'll just change this. Instead of minus 2, I'll make it some other number like 3 or something. Okay, okay. So minus 3 is less than 0. Okay. Now what do we do? How is this any better than before? So I'll do 2x plus 1 minus 3 times x minus 3. So the numerator becomes how much? 2x minus 3x, which is minus x. And then plus 1 plus 10, I guess, right? Plus 9, which is plus 10. Please stop me here. If I'm doing some silly mistake, please watch out and just call me out. Okay, minus x plus 10 upon x minus 3. Okay, so we want this. Okay, I'll write it as 10 minus x by x minus 3 if you want. I'll write it like this, right? Either way, 10 minus x minus 3 doesn't matter, less than 0. Okay, now how do we solve this? We use the sign test. What is the sign test? We have a collection of terms in the numerator and denominator. In this case, there's only one term in the numerator and one term in the denominator. By term, I mean multiplicative term. For example, if it's 6 minus x times x minus 3 times x plus 4, it's 3 terms, right? A term means a multiplicative term. So in the numerator, there's only one term, 10 minus x as a unit. As a multiplicative unit, there's only one term, right? And the denominator, there's only x minus 3, right? So I will look when each of these terms becomes 0. So my critical points are x equal to 3, x equal to 10, right? I don't even have to mark 0 here. In fact, don't mark 0 unnecessarily. 0 is just another number. It does not need to be given special status. As far as this problem is concerned, 3 and 10 are my critical points. So that divides the number line into 3 regions. To the left of 3, between 3 and 10, to the right of 10, right? In each region, I analyze what's happening. So to the left of 3, I'll take one example, left of 3, let's say 2. The numerator is also positive. The numerator is positive. The denominator is negative. Because if I put x equal to 2, I'll put it here, right? 8 by minus 1, which is negative, right? So I'll put negative signage here. If it's between 3 and 10, let's say a number like 5. So the numerator is 5, the denominator is 2. It's positive. Typically, you will see this. They'll alternate between plus and minus. If you get the boundaries right, then it should be alternating between plus and minus, except there are a few exceptions. We'll go over it later, right? And if it's 10, beyond 10, let's say it's 12. 10 minus 12 is minus 2. 12 minus 3 is 9. Therefore, it's negative. So the region that we want is when this guy is less than 0. Therefore, we conclude by saying x should be less than 3 or x should be greater than 10. The word or is important. it should not say and. If you say and, it's meaningless, right? How can x be less than 3 and be greater than 10 simultaneously, right? It's like saying there's no solution at all. So use the word or versus and very clearly, right? X less than 3 or x less than 10. In another problem, suppose it ends up being in the in-between region. Let's say the answer is between 2 and greater than 2, less than 5. Then you should say and. You can either write 2 less than x less than 5, right? That's one way of writing, or you can write it in a different way. You can say x is greater than 2 and x is less than 5. In that case, it's restricted between this band, and therefore you use the word and. Don't use or there. If you use or there, then it means all possible values of x, because you're saying you'll accept anything which is more than 2. You'll also accept anything that's less than 5, which means entire in minus infinity to infinity will fall in that, right? So be very careful when to use and, when to use or. Okay, these are all subtle things. Not all of this will be relevant for AMC10, but it's very useful to watch out for these small things. Okay, all right, so that is that. And now absolute value is also important, right? Absolute value, what is the definition of absolute value? If you just see fundamentally, absolute value of A, right, is nothing but if A is greater than or equal to 0, okay, then you don't have to do anything. So the absolute value of A is A if A is greater than or equal to 0. But if A is negative, then you put another negative to make it positive, right? It's minus A if A is less than 0. That's what the definition of absolute value is, right? So suppose someone asks 2x plus 7, solve for it to be less than 11, right? That means 2x plus 7, right, must be less than 11 and greater than minus 11, because in magnitude, it must be less than 11. So it cannot be a stronger negative than minus 11. It has to be a weaker negative than minus 11, meaning numerically, it must be between 0 and minus 11, right? If it's a negative number. So we can summarize this as 2x plus 7, and then we can solve this separately, right? I can subtract 7 on both sides. So I can subtract 7 on both sides. This will become 4. This will become minus 18. I've subtracted 7 on both sides. I can divide both sides by 2, and therefore there's no, since 2 is a positive number, there's no changing of sign. So I'll end up writing this, right? On the other hand, if it's, right, all okay, good on this one, right? On the other hand, if it's 5 minus 3x is greater than 10, okay, then we have to say this means 5 minus 3x is greater than 10, right? Or 5 minus 3x is stronger than negative 10 in the negative direction. So stronger meaning more negative, right? That's when in magnitude, it'll be more than 10. And therefore, this has to be solved separately. So which means 5 minus 10 is greater than 3x. Let's see what this comes out to be. So which means x is less than minus 5 by 3, right? Right? I'm not changing sign here because 3 is just a positive number. By the way, if I write this way, it's not like I'm changing sign. I'm just rewriting this exact same statement, except that I've brought the x to the left side. So it's not, I'm not changing sign per se, right? I'm just bringing x to the left side, that's it. Because it's always useful to have the variable on the left side. Maybe at the beginning itself, I should have done that rather than bring the 3x to the right side. So in fact, I'll redo this so that we are all, so x less than minus 5 by 3, we should still get x less than minus 5 by 3. So let's redo this in a different way. So we'll do 5 minus 3x is greater than 10, right? So minus 3x is greater than 10 minus 5, which is 5. Now we'll divide both sides by minus 3. Therefore, we have to change the sign. Therefore, we'll say x is less than minus 5 by 3, right? So this is one part. Or this one is 5 minus 3x is less than minus 10. So minus 3x is less than minus 10 minus 5, which is minus 15. Divide both sides by minus 3. Therefore, change sign. X is greater than 5. And or here. So the solution for this is x is greater than 5. So bigger than a certain positive number. It doesn't have to be positive. In this case, it's positive. Or smaller than a smaller number. So if it's bigger than a bigger number and smaller than a smaller number, it's or. If it's sandwiched between a small and big number, it's and. Okay.
So,
yes, Drishit.
so modulus and magnitude are different things, right?
They're same. But modulo is different. Modulo is the remainder. When you say people
No,
talk
so
about
but like usually when there's like a modulus value, it can't be negative, right?
correct.
So then how can it be negative in this?
X can be negative, right? So
Oh,
absolute value of 5 minus,
yeah.
we are asking what should X be such that absolute value of 5 minus 3X is greater than 10. You're right that absolute value of 5 minus 3X
Yeah.
is, okay. Okay, all right. Makes sense, right, Dishit?
Yeah.
Okay, all right. Can you guys, so I'll just give one example. Can you guys solve this one just for practice? So mod of minus 2x minus 13 is less than minus 11. Can we solve for this?
So how can a positive be less than a negative?
Excellent. Yes, it's a trick question. So don't blindly start solving every problem just on the face of it. Very good observation. Going back to exactly what Drishit just said, right? Absolute value is just a positive number. How can a, or rather non-negative number be less than a negative number? It's meaningless, not even possible. So no solution straight away, right? No solution straight away. Very good, Kunal. So the reason I gave you this problem is don't blindly start algebraically solving. Think, kya ho raha hai, thoda socho, right? So no solution. Likewise, if there's another problem like this, like 99x minus 1000 is greater than minus 2. Okay, Vihan, what will the solution for this be?
No solution.
All solutions, all x will satisfy this because this left-hand side is guaranteed to be 0 or more. So no matter what x is, it'll be 0 or more because I'm putting absolute value, right?
Oh wait, it's greater. Yeah, all solutions.
Right? All real values. So we don't have to spend time at all for both of these problems. No solution if you just look at it, and all solutions if you just look at it, right? Thoda, just take a glance without before jumping into problems. Shivank, all okay on this one?
Yeah.
Okay. All right. Okay, so that's okay. Yeah. Next, absolute value, we can be mixed with absolute value can be mixed with non-absolute value. So by that, what do I mean? So okay, I'll erase this. I need space. So suppose I have 2x plus 3 is less than 5 minus x, right? Something like this. In fact, I'll give a little bit round number so that it's easy. Otherwise, we'll be spending a lot of time on fractions. I'll just say 2x plus 6, right? Less than 5 minus x. Now, how do we approach where things are mixed? Okay, so the way we do this is, again, we'll look at what will cause 2x plus 6 to become 0, right? 2x plus 6 will become 0 when x equal to minus 3. So on the number line, I'll mark minus 3, right? And then I'll divide the problem into two parts. If x is less than minus 3, and if x is greater than or equal to minus 3. So I'll have two parts. I can include minus 3 anywhere, so either on the right side or the left side, but doesn't, because 0, absolute value of 0, 0 only. I'll divide it two parts. X is less than minus 3, x is greater than or equal to minus 3. So in this region, right, x is less than minus 3, then 2x plus 6 is negative, right? 2x plus 6 is negative, which means what is absolute value of a negative number? It's negative of that negative number. So as far as this region is concerned, it's just 2x plus 6 with a negative sign. That's what the absolute value is. Ananya, are you with me? Right? Is less than 5 minus x. And we know how to solve. There's no absolute value, just solve blindly. Okay. Similarly, on this side, which x is greater than or equal to minus 3, 2x plus 6 will be positive. Therefore, the problem is just 2x plus 6 is less than 5 minus x. And then solve it normally. So let's solve both of them normally. So let's see. Minus 2x. Let me bring the minus x to this side. So minus 2x plus x will become minus x. And then I'll get the numbers to the right side, right? So this is minus 6, which goes to the left as, right? 11. 5 plus 6, which is 11. And let me remove the negative sign. I'll divide both sides by minus 1. X is greater than minus 11. Right? Am I right? Minus 2x plus x. Minus x is less than 11. X is greater than minus 11, which means in the region x less than minus 3, I will take all solutions where x is greater than minus 11, which means the intersection of these two is the solution for the left-hand part, right? So which means minus 11 less than x less than minus 3. It should be more than minus 11, but I'm operating in the region which is less than minus 3. So my solution for the left-hand part is minus 11 less than x less than minus 3. Right? Now I'll come to the right-hand part. Okay. So right-hand part, I'll solve it again. Same thing. So 2x plus 6 is less than minus. So minus x I'll bring to the left-hand side. So 3x less than minus 1. I divide both sides by 3.
So,
Yes.
when like in the minus 3 part, why did you put a negative before 2x plus 6?
That's what I started off by saying, right? If x is less than minus 3, then 2x plus 6 is negative.
Yeah.
If 2x plus 6 is negative, the absolute value of that negative number is negative of that negative number. Are you with me?
Yeah. Yeah.
Yeah?
Yeah.
No, it doesn't seem like a confident yeah. Pakka?
So,
Okay. There is this guy. If this guy is positive, then it's this guy itself, right? Whereas if this guy is negative, then it's the negative of that guy, right? Only then negative or negative will become positive.
which the absolute value of a positive number is a negative number.
No, absolute value of a positive number is itself. So this is if positive, this is if negative.
Oh, so then like there should be a negative sign with that guy, right? Inside the bracket.
No. See, 2x. Okay, so I'll give an example, right? Let's take an example which is less than minus 3. Give me a number which is less than minus 3.
Minus 7.
Minus 7. So if x is minus 7, what is 2x plus 6? Minus 14 plus 6, which is minus 8. I'm talking about absolute value of minus 8, correct? Absolute value of minus 8 is 8, which is nothing but, how do I get this 8? Using minus 8. I say it's 8 is nothing but minus of minus 8. In other words, it's minus of 2x plus 6.
Okay, yeah.
All right, very simple, Kunal. You don't need to confuse. If some quantity is negative, then absolute value of that quantity is negative of that negative.
Yeah.
Right?
Yeah.
That's all I'm doing. 2x plus 6, I know in this regime is negative. Therefore, absolute value has to be negative of that 2x plus 6.
Okay, yeah, got it.
Yeah, sure. Whereas on the right-hand side, when x is greater than or equal to minus 3, I know 2x plus 6 is already positive. So the absolute value does not mean anything to me. I can remove it completely. Makes sense?
Yeah.
Yes, Kunal? Okay.
Yeah.
So just completing this one. So I didn't have to put the absolute value here because x is 2x plus 6 is positive in this regime. Therefore, I'm dividing both sides by 3 now to complete this. So x is less than minus 1/3, right? So what is this guy saying? If x is greater than minus 3, if I'm operating in the region x is greater than minus 3, then the solution I'll accept is as long as it's less than minus 1/3, which means combining both of them, I will say the right-hand solution combined is minus 3 less than or equal to x less than minus 1/3. Okay. Right. So far you're with me. And now we have to combine this guy and this guy, right? My total solution is a complete package, right? I'll accept all of these values which sit between minus 11 and minus 3. I'll accept all of these values which sit between -3 and -1/3. Now, -3 in this case, it so happens that is the same -3 that's appearing on the left here. So I can completely connect both of them as one and just say, this is my full solution. Full solution. Does it make sense? Apurva, you're with me completely on this? Sana, you're good? Yeah?
Yes.
Okay. Cool. So that's how we approach absolute value problems when you have a mix of absolute value or non-absolute value, right? And if you have both absolute values, then it's slightly easier. So suppose I have 3x plus 1 is less than x minus 2, like this. Then I have two approaches, right? I can square both sides. Say, because 3x plus 1 absolute value is a positive number. So 3x plus 1 whole square is also a positive number. So this is effectively saying, so what is this guy saying? In magnitude, which means without the signage, 3x plus 1 should be a weaker quantity than x minus 2, right? In magnitude, right? In magnitude, it must be, so for example, 3x plus 1 could be 7. X minus 2 could be -9. In magnitude, 3x plus 1, is it smaller than x minus 2? Yes. And we'll accept that, right? So another way of saying the same thing is, if I square 7, it's less than -9 cos square, right? So effectively, it's saying 3x plus 1 whole square must be less than x minus 2 whole square. Yeah, does it make sense? Everyone, Dishit, you're okay on this?
Yes.
Both are equivalent, right? And now I can convert this to a quadratic and solve. So we'll go into quadratic shortly. But let's say 9x square plus 6x plus 1 is less than x square minus 4x plus 4. I'll bring everything to one side. 8x square plus 10x minus 3 is less than 0.
But
Okay.
so if you've got to that step where it's like the square is less than that square, then you can take square root on both sides and say that is less than that.
No, for the precise reason that we just said. Yeah, you can do, correct. You can take the square root. But what will the square root of 3x plus 1 whole square be?
3x plus 1.
No, what if 3x plus 1 is negative? Are you with me?
Yeah.
In other words, square root of, forget this problem, all right? If someone asks you what is square root of b square, it is not b. It could be, it is b if b is positive. It's minus b if b is negative. So square root of b square is technically this. Does it make sense?
Yeah.
Yeah. So in other words, I cannot, if I take the square root, it'll be back to this. The square root of 3x plus 1 whole square is absolute value of 3x plus 1. It's not 3x plus 1. Then we are back to the same challenge.
Okay.
Makes sense?
Okay.
Right? And you understand also why, right? Because
Yeah.
so suppose I'm giving like this, right? Then you'll answer 7. You won't answer -7, right? Which means in terms of the given number, it's minus of -7. Correct? If you say B, it's not obvious. If you say -7, then the problem becomes very apparent, right? The square root of -7 whole square is not -7. It's +7. Correct? Right? Whereas square root of 5 square is 5. So how do I combine both of these situations? I will say square root of b square is absolute value of b.
Yeah. But in this sum we are doing with the absolute value of 3x plus 1.
Correct. Is less than absolute value of x minus 2. So
If 3x plus 1 is negative, then it's not like the -7, because the negative is accommodated inside the 3x plus 1, right?
yeah.
You don't need to write a -7. We can write like how you wrote in the first example, a b, just a square root of b square.
I'm not entirely following what you're saying. Okay, let me just, so basically, if I'm saying mod A is less than mod B, right?
Yeah.
Then I cannot say A less than B or A greater than B. None of this, I cannot make any such inference.
No,
I can
but you
only,
can, right? Because when both are positive,
when both are positive, there's no doubt at all, right? The problem is you don't know what x is. There could be values of x, which results in 3x plus 1 being negative.
Okay, yeah, you're right. Yeah. Okay. I
Makes
got
sense, right?
Yeah.
Sure,
So
Pakka. Yes.
I have a question. So
Yes, Darshit.
if you have like x plus 1 whole square is equal to 49, so then would you get x plus 1 as -7 plus 7 or only +7?
Okay. All right. Let's recap that. Forget even x plus 1 whole square. Suppose x square is 49. Then you say x is plus or minus root of 49. Root
Yeah.
49 is always the positive root. Therefore, you'll complete it by saying x is plus or minus 7. This
Okay.
is one problem. But suppose in another problem, suppose
Yeah.
someone gives x is root 49. Then you should say, which means x is only 7. These two are different problems. The first problem has two solutions. The second problem has only one solution.
Yeah, got it.
Root signifies only the positive root. Yeah, sorry, was there another?
Square root, why don't we take plus minus value?
The definition of square root is the positive root. That's how they have defined. Square root means the positive square root. You have to explicitly put the plus minus outside it to indicate that. Okay. All right. So which is why in the quadratic formula also, if you see, it's minus b plus or minus square root of b square minus 4ac. If the square root of b square minus 4ac could be treated as either positive or negative, then you don't need this plus minus. No. You put the plus minus because what follows is always positive. You have to explicitly put the plus minus. Does it make sense, guys? Okay. All good questions. Keep them coming. Okay. All good. Any other doubts, guys? Apurva, all okay? Kunal, all okay? Sana, Anahat? All good, right? Okay, cool. Right. So how do we finish this problem, this quadratic? So we'll do quadratics in a bit more depth. But for solving any quadratic inequality, just assume it's equality for now. Suppose it's equal to 0. The roots of the quadratic are minus b plus or minus root of b square minus 4ac whole by 2a, right? So let's do that. So the roots would be minus 10 plus or minus square root of 100 minus 4ac will become minus 4 into 8 into 3. So it'll become 4 into 8 into 3 is how much, guys? 72, I guess, right? 96. Oh, nice. It worked out to be a round number, although I didn't plan it that way. 196 is a round number. It's a perfect square, right? So great. So it becomes easier. So upon 16. So it's minus 10 plus or minus 14 upon 16. So minus 10 minus 14 is minus 24. Minus 24 by 16 is minus 3 by 2. Plus is 4 upon 16, which is 1/4. So the roots of this guy, right, are minus 3 by 2 and 1/4, which means when we plot a quadratic, okay, I'll just make more space and erase this. Okay, so when we plot this quadratic, okay, so there'll be two roots, right? The two roots. Okay, I'll just. Okay, the two roots are, this is one root, which is minus 3 by 2. And this is another root, which is 1 by 4. Okay, the two roots are this. Now you analyze which is the region we want, right? In this region, only I can shade properly. So in this region, the y value, this is y, right? This is y value. Y value is positive in this region, right? And this is the y, right, that we are looking at. This entire thing is a y. Y is a function of x, right? Whereas in the middle region here, it's negative, right? What is it we want for our problem? We want it to be negative. We want this expression to be negative. Therefore, the solution is minus 3 by 2 less than x less than 1/4. Does it make sense? Yeah? Oh, the shading is clear, guys? Bihan, Anahat, your videos are off. I don't know who else is off, but okay, all okay, right? Anahat, you're all okay, right? All of this is straightforward, right? Okay. Okay, next is telescopic cancellations. Telescopic, you're good in this one? Quadratic. We'll do quadratics a little bit more depth, but this is what was needed for this problem. Yeah, question.
So I need to leave actually. I have to go somewhere.
That's fine,
I'll
that's
go
fine.
to the recording.
Yeah, please do.
Bye, sir.
So telescopic cancellation is problems like, there could be like multiple problems like this, right? Like an infinite series. So one example could be x equal to 2 plus 7 by 2 plus 7 by 2 plus 7 by, and so on, right? So for this, the standard approach is, you see when the pattern repeats. So x is 2 plus 7 by, what follows is x itself. If you look at this infinite series, it's what we started off with. So that is the x. And then you can just solve this from here. Sorry?
Yeah.
Okay. And therefore we can solve it. If you multiply by x, it becomes x square minus 2x minus 7 equal to 0. And then we can solve 2 plus or minus root of b square minus 4ac will be 28 in this case, whole upon 2a. So it's 2 plus or minus root 32. 32 is 4 times, sorry, 16 into 2, therefore 4 root 2. So it's 1 plus or minus 2 root 2. But it's a positive quantity. Therefore, it has to be only 1 plus 2 root 2. Okay. And then we can do some simple sense checking, right? So 2 times 1.4 is how much? Root 2 is 1.4. So 2.8 plus 1, right? So this quantity is 2.8 plus 1, which is 3.8. Okay, so we can roughly validate if this makes sense. We are saying 3.8 is 2 plus 7 upon 3.8. Is that true? Roughly we can check, right? So 7 upon 3.8 is slightly less than 2, right? Because 3.8 times 2 is 7.6. So in the numerator, we have 7.0, not 7.6. And therefore, arguably, this is maybe 1.8, 1.9. So 2 plus 1.9 is 3.9, roughly okay. Just very simple sense checking you guys should always do, right? If, for example, in this, suppose I make a mistake, instead of 3.8, I made a quick mistake, 5.8. Then my sense checking will catch it. I will see if 5.8 is 2 plus 7 upon 5.8. Right? It'll be obvious no, because 7 by 5.8 is 1 point something. How can 2 plus 1 point something add up to 5.8? It's wrong. So catch silly mistakes with a simple sense check. It hardly took 5 seconds, right? And even less if you're just doing it for yourself. For me to explain itself, it took only 5 seconds. For you to do it quickly, it won't even take that much. But get into the habit of doing sense checking at every step. Especially at the very end, put back in the original question and sense check. Okay, so telescopic cancellation is also for example, suppose I have 1 by 2 into 3 plus 1 by 3 into 4 plus 1 by 4 into 5 all the way, right? Anahat, do you know how to approach this kind of problems? Suppose this goes on till infinity. What will the sum of this be? I'm calling Anahat because he's been very quiet today.
Yeah, sorry. Once I'll think about it. I think
Okay.
I remember we had done that, but I forgot. I'm just thinking about it.
Okay. All right. If you knew offhand, I was going to ask you to, but anyway, so I'll just recap for everyone. So we'll replace, yes, anyone.
Will it be near 0?
No, it won't be near 0, right? In fact, let's do it and solve. It won't be 0. In fact, why will it be 0? It's 1 by 6 plus 1 by 12. There's no, in fact, it's getting bigger and bigger, right? Even with the first term, it's 1/6, right? You are only going to make it more than 1/6 by adding more and more positive terms, right? So it'll be some finite quantity. Okay, so the trick here is replace the 1 in the numerator as 3 minus 2, right? And this is multiplication, not decimals, right? I'm just saying 2 times 3 plus 4 minus 3 by 3 times 4 plus 5 minus 4 by 4 times 5 and so on, right? And now 3 by 2 times 3 is 1 by 2. And the minus 2 by 2 times 3 is 1 by 3. Similarly, the next term here is 1 by 3. And this next term is 1 by 4. And now we can see a lot of cancellations, right? And so on, right? So this will cancel this, this will cancel this, this will cancel this, right? If it goes till infinity, then the last term will be 1 by infinity, which is 0, which means it will approach half. Doesn't make sense, Vihan. It approaches half, not 0. But on the other hand, it need not be till infinity. For example, they might stop at 1 by n times n plus 1. In that case, the last term will be 1 by n minus 1 by n plus 1. That's how it will finish. So everything till n will get cancelled. the only prevailing term will be half and 1 by n plus 1. In that case, we'll say 1 by 2 minus 1 by n plus 1 and simplify whatever that is. And clearly, as n tends to infinity, this goes to 0. The answer is just half. Yeah, all okay. Sana, completely with me. I can hardly see your face, Sana. Can you shift your monitor so that I can see your full face? Who else is like that? I think everyone else is fine. Kunal, you also, I cannot see your full face better. So you're on the right corner of my screen, right? So just adjust so that I can see your face. I read a lot from your expressions, guys. So, which is why I keep asking you to have the video on. Okay, all right. So that's telescopic cancellation. And not always it'll be like a laddu like this, right? They could twist it. For example, they can have, I don't know, 3 by 4 into 8 plus 3 by 8 into 12 plus 3 by 12 into 16, right? Now, what can we do? We can take 3 common outside. That's first thing. And then how we want to write it as 8 minus 4 by 4 into 8. And we want to write this as 12 minus 8 by 8 into 12, so that we can follow the same approach as before. But the numerator is 4, 4, 4, 4, right? We want 1, 1, 1, 1, but no problem. I'll divide by 4 and compensate. That's it. We wanted a 1. We wrote it as a 4 by 4. We use the 4 as 8 minus 4 or 12 minus 8 or 16 minus 12 and so on. And then it becomes the same problem as before. So it becomes 1 by 4 minus 1 by 8 plus 1 by 8 minus 1 by 12 plus 1 by 12 minus 1 by 16. So you see the bunch of cancellations all the way till the end. Maybe depending on what the last term is, or goes to infinity, you can do it. So the trick is taking out common, whatever stuff is common, and then multiplying and dividing by whatever quantity you need. So in this case, 4 helps. So I'll divide by 4. So that you can use the 4 in the numerator. Okay, Apurva, all good? Makes sense so far? Okay. Now, quickly, let's recap quadratics. Right, quadratics is very important, all-pervasive topic, right? It's there in every, right? So if I have 2x square plus, okay, I'll just start with x square. So suppose I have x square plus 6x minus, okay, fine, plus 8. Then we know I can easily factorize this as x plus 2 times, suppose equal to 0. Okay. So first of all, this is an equation, quadratic equation. Suppose you don't have equal to 0, it becomes a quadratic expression, right? So that subtle difference you guys should know, right? An expression can be plotted. For example, without the 0, I can plot this quadratic function, right? Expression, function, more or less same thing, right? This is an expression. Once you put y equal to this, it becomes a function. So y is a function of x. So for different values of x, you have different values for y, right? Whereas if I have x square plus 6x plus 8 equal to 0, there's no function. You cannot plot this. You cannot plot this. It's meaningless. You can only solve this. So solving means what values of x will make this equality come true. That's what solving is. So you can find roots. You can solve to find roots or solutions. They mean the same thing, right? Or sometimes the people say zeros, right? Roots, solutions, zeros, they all mean same thing, right? And note that the right-hand side need not be always 0. For example, the problem could be like this, minus 19. As long as you can write something equal to 0 by pushing stuff around, it still remains an equation. So don't think the equation has to be always ending with equal to 0, right? You can manipulate it and write it as equal to 0. Okay, so coming back to quadratic, okay, but let's start with the quadratic equation itself, right? So suppose I have to solve this guy equal to 0, I can factorize. I can factorize this as x plus 2 times x plus 4. And then if product of 2 terms, note that there are 2 terms, right? As I always say, it's 2 multiplicative terms. How many terms are there within that? I don't care. For example, if I have 2x plus 7 minus 3y times x plus 2, it's still 2 terms for me. This term and this term. I always look at product-wise. Product-wise, there are only 2 terms. Within each term, there could be multiple subterms, right? So back to this question, x plus 2 times x plus 4 is 0. Again, I'm repeating some of the common knowledge only. So if I have product of several terms is 0, at least one of them has to be 0, which is why we conclude by saying x equal to -2 or x equal to -4. And then we're done, right? But not always things are factorizable, right? So instead of x square plus 6x plus 8 equal to 0, had it been x square plus 6x plus 4 equal to 0. Then how do we solve this? So we solve either by completing the square. So this technique called completing the square, which is how you get the quadratic formula itself. Okay, but you understand how the completing the square works. That'll be useful, right? So we know that p plus q whole square is p square plus 2pq plus q square. So we'll follow the same model. So we'll write it as x square plus 2 into x into what will make it 3x, 2 into x into 3. Okay, and then I'll add 3 square, which is equivalent of q square. So I've discovered my q is 3. I'll add 3 square, and I'll add 3 square to the right hand side as well. And then there's plus 4, of course, which I'll carry in the problem. All I've done is I've written the 6x as 2 times x times 3, and then I've added 3 square on both sides. So why is that helping me? Because I can write it as x plus 3 whole square equal to, I'll move the 4 to the right hand side, 9 minus 4, which is 5. And therefore I can complete it by saying x plus 3 is plus or minus root 5. Note that plus or minus root 5, Ananya, right? Not just root 5, because root 5 is only positive root 5. I'll have to explicitly put plus or minus outside. And therefore x is minus 3 plus or minus root 5, right? That's exactly what you'll get by using the quadratic formula and solving. Let's check that. The quadratic formula, as we know, is minus b plus or minus root of b square minus, Shivank, you remember the quadratic formula, right? 4ac, yeah, Shivank? Okay, whole by 2a. So let's check if we get the same answer. Minus 6 plus or minus root 20. 20 is 4 times 5. So root 4 can come out as a 2. Right? I can cancel off the 2 to give 3 minus 3 plus or minus root 5. So the quadratic formula is also telling you the same result. Okay, so the two roots alpha and beta of the quadratic formula ax square plus bx plus c are this minus b plus or minus root of your b square minus 4ac is your discriminant. Right? B square minus 4ac is the discriminant. We did quadratics in detail, right? So by 2a, right? Now, when we have a quadratic, the two roots are where it cuts the x-axis, right? So this is, so let's say this is my alpha and this is my beta. Now the vertex, which will be exactly beach of the two. The x coordinate of the vertex will be the average of alpha and beta, right? So average of alpha and beta will be about, so the plus root d and minus root d will get cancelled. So it'll become minus 2b by 2a divided by 2, right? Minus b plus minus b bond 2a. Because of the average, I'm dividing by 2. So it's minus b by 2a. So the x coordinate of the vertex is minus b by 2a. And the y coordinate of the vertex, you can substitute the x coordinate and see what you get. And that turns out to be minus d by 4a, where d is this important quantity, b square minus 4ac. Okay. And then we also know that depending on whether the discriminant is less than 0 or discriminant is equal to 0 or discriminant is greater than 0, the quadratic function will either be not touching the x-axis at all, or just grazing the x-axis, or cutting the x-axis in 2 points, right? In other words, it'll have either no roots if you set it equal to 0. The function itself, we cannot talk about whether it has roots or not, right? The function does not have roots anyway. You can only plot a function. But when you set it, when you set ax square plus bx plus c equal to 0 and ask yourself how many roots that has, you'll say yes.
Wouldn't the discriminant have to be less than 0 for it to have no root?
Yes, that's what I said. Discriminant is less than 0, no roots.
Okay.
Right? Yeah, 2 roots here if discriminant is greater than 0. So the case where one root, people also called repeated root. Technically, there are 2 roots here also, but the 2 roots are coincident. Coincident roots or repeated roots. By the way, technically, even for discriminant less than 0, there are 2 roots. But those roots are complex roots or imaginary roots, which is why we are not able to see it on the real axis. We cannot see it cut the real axis somewhere. Okay. And then, So in other words, I can write the quadratic. So I have ax square plus bx plus c. Okay, I can write it as a times x minus alpha times x minus beta, where my alpha and beta are whatever we saw, right, multiple times, right? Alpha and beta are the minus b plus or minus root d by 2a, right? I can also write it as the vertex form. So this is the normal form. The second one I have is the factorized form. Why is it called factorized form? It helps us call out what the roots are, alpha and beta, if you set it equal to 0. Roots of the equation y equal to 0, right? Again, I keep repeating, these are all very subtle things. A function does, you don't need it necessarily for AMC10. They're not going to trick you whether it's a function or an equation, but broadly you should know what's happening, right? Right. Now, you can also write it as a vertex form. I'll tell you, right? Right, this is the vertex form. So vertex form means what? I can read off the coordinates of the vertex right from here. The vertex coordinates are h comma k. So, right, and our h is what we just saw, right? Minus b by 2a is the x coordinate of the vertex, and minus d by 4a is the y coordinate of the vertex, right? So for example, if someone says 2 times x plus 3 whole square plus 7, that means it has a quadratic with a vertex. In fact, I'll put minus 2 times, right? It's an inverted quadratic because it's minus 2, right? And the vertex coordinates are x minus minus 3, right? Therefore, the x coordinate is minus 3, and the y coordinate is whatever outside here. So minus 3 comma 7, right? So minus 3 comma 7 is the vertex. So if you look at it, if I draw x-axis and y-axis like this, my quadratic will be with a vertex of minus 3 comma 7. Let's say minus 3 comma 7 is here, and it'll be downward going like this, something like this. Okay. Okay, any questions so far on quadratics, guys? All okay? Okay. And then the concept of sum of roots and product of roots. So the sum of the two roots is, again, the root d gets cancelled. So here it's sum, not average. Average of the two roots is alpha plus beta by 2, which is minus b by 2a that we saw here. So sum is just minus b by a. And the product is c by a. Right? And this is useful because I can write a quadratic. So suppose I have a times x minus alpha times x minus beta equal to 0. Right? So first of all, I can divide by a. So as far as equal to 0 is concerned, the a is meaningless. I can divide by a and make it just simply x minus alpha times x minus beta equal to 0. So I can expand this as minus alpha x minus beta x plus alpha beta equal to 0, which means it's x square minus alpha plus beta times x plus alpha beta equal to 0, which means a quadratic is just x square minus sum of roots times x plus product of roots equal to 0. Sorry, did someone chat me? I'm just seeing this now. Oh, okay. Anahat, I'm just seeing your message only now, or he's already here.
I was gone for a minute.
Oh, okay, okay. I'm sorry. Okay, but you're back now. Okay, good. So x square minus sum of roots times x plus product of roots. So this is useful if they give you the sum and product of, for example, if they ask you, find a quadratic equation where the roots add up to 11 and the roots multiply to 13. If you start guessing what two numbers will add up to 11 and multiply to 13, you'll be nowhere, right? Because 13, first of all, is a prime number, right? So 1 and 13 are the possible choices that they don't add up to 11. But using the sum and product, you can easily say it's x square minus 11x plus 13 equal to 0. You don't care about the roots. You're given the sum and product. In fact, that's how you start off, right? Given this, suppose you'll have to guess what the roots are. You'll find two numbers which add up to 11, minus 11 rather, and add up to 13, right? Ignore the small minus versus plus. Because it's minus 11x, the sum turns out to be 11. There's x square minus sum of roots into x plus product of roots. So, but roughly, when you're given this, you will find two numbers that add up to 11 and multiply to 13, right? Which you're not able to, which is why you resort to the quadratic formula to solve. But if you already know the sum and product, you don't even care what the roots are. You directly write the equation as x square minus 11x plus 13 equal to 0. Okay, Shivank, you're okay? Understood this point?
Yeah.
Okay. All right. quadratic we did. Okay, floor, seal, round, all of this you should know, right? So round we know, rounding of any number, 7.8 is just 8. Okay, so floor and ceiling. So this is used to denote floor. So floor of 7.8 is 7. So is nothing but, it's also called the integer function, int of 7.8. Floor and int, so this is called floor function. Okay, so if it's an integer, then you just keep that integer as it is. If it's a non-integer, you go down till you hit an integer. So int of 7.8 is 7. Whereas suppose I have int of 6 is just 6. Whereas suppose I have int of minus 5.1, it's minus 6, because minus 5.1 is not an integer. You go down till you hit the next integer, which is minus 6. Exactly reverse process for ceiling. So ceiling of 2.3 is 3. If it's an integer, you just stop there. So ceiling of 4 is 4. But ceiling of 2.3, it's not an integer. You go up till you get the next integer. So ceiling of minus 99.7 is minus 99, because you go up to reach minus 99. So floor and ceiling are important. Functions. So I don't know what I had in mind when I said functions. In general, okay, so one thing you should know is, if I have a function f of x, right, y equal to f of x, you should know a few transformations that can happen to it. So what are some of the transformations? If I have f of x plus 3, for example, then it's shifting up by 3, correct? Now, if I have 2 times f of x, right, that's stretching it by a factor of 2, right? It's elongating it by factor of 2. If I have minus of f of x, so this is stretching. So this is stretching. This is shifting up in this case, right? And if I have minus of f of x, it's reflection, right? Reflection about in a vertical direction, right? F of x is, let's say, going up, minus f of x will go down. So it's reflection vertical direction, or rather reflect about the x-axis, right? Now, all of these same operations you can do on the horizontal also. So, for example, suppose I had f of x minus 5. That's also a translation. That's also shifting, but it's shifting horizontally, right? Anahat, this is shifting horizontally to the right or to the left? F of x minus 5. Anahat. Oh, you cannot unmute. Okay. Yeah, now you are. No, I cannot hear you, Anahat. Okay. You always have trouble with this mic. I'm not sure. Kunal, what do you think? F of x minus 5 is shifting to the right or shifting to the left?
The right.
Because I asked this question. Okay. Okay, Apurva, what do you think?
Yes, sir, right.
Shifting right. Yes, you are both are right. You both are correct. It is shifting to the right. So it's little counterintuitive. So f of x minus 5 is shifting to the right. So shift. Yes, Anahat, I can hear you now.
Oh, finally.
Okay, so but given that you're unmuted, I'm going to ask you this one. So f of 3x,
Right.
what will this do to f of x?
This will make it steeper.
What do you mean steeper?
Like, okay, shift to the left. It'll just
No, shifting right or shifting left?
No, not shift. Like steeper, as in the slope will increase. The gradient will.
Not quite. So for example, okay, let's say f of x is sinusoidal. Then what do you mean by a slope, right? Let's say f of x is like this. Then what will f of 3x look like?
F of x is like this. F of 3x will. Okay. How do I explain this? Basically, okay, the derivative at but again, because there's a stable point that you can't. It will just basically like become the gradient will be increased by a factor of not 3 exactly, but the gradient will increase at most points except the
Yeah,
stable
yeah,
point.
you're partially right. So basically, it's also a stretching, but it's stretching horizontally, right? But actually, it's not stretching; it's shrinking here, right?
So it,
Yeah.
so it stretches horizontally if like if for example if you consider 3 as A, it only stretches horizontally if A is between 0 and 1, and it shrinks if A is greater than 1.
Exactly. Or if you want to just think, just to repeat exactly what Apurva said. So in this case, f of 3 times x, 3 is a number greater than 1. So f of 3x is actually shrinking, which means, all right, so the sinusoidal in this example will now become like this. It'll oscillate more frequently.
Yeah, exactly. So the gradient just increases on
The gradient
points.
at every point is 3 times. Yeah.
Yeah.
Right. But the y value itself will remain the same. So,
Yeah.
so as opposed to, I want you to contrast this with this. So in this case, let's say the function was again the same sinusoidal. Let's say the base function was this, still the same. So in this case, it's 2 times f of x, which means the period will still be the same, right? So if I have to overlay this, so this will become double. It'll vertically stretch by a factor of 2. So that's this guy, right? So whereas if it's f of 3x, it's not stretch, it's actually shrink by a factor of 3 horizontally, as Apurva was saying, right? And hope I didn't confuse you guys more.
So
But
basically, like it's an inverse twice, right? Because like what's happening when you multiply it inside, when you do f of 3x versus 3f of x, it's like horizontal stretch becomes vertical stretch when a is greater than 1, and when it's in the middle of 0 and 1, it shrinks, which was happening when it was greater than 1 earlier.
exactly, right? So if I have, in other words, if I have f of x by 2, right, as he was saying, that's actually stretching by a factor of 2, right? This stretching, it's becoming stouter, stretching by 2, right? It's becoming fatter. F of x by 2 is a slow moving function. F of 3x is a fast moving function, right? The period, just think of it this way. When you have f of 3x, just always think of it in terms of a cyclic function, which repeats. So the period has shrunk, or rather the frequency has become 3 times. In this case, the frequency has become half, means it's becoming stouter or slow moving function. Okay, and the equivalent of minus f of x is f of minus x, right? F of minus x is reflection horizontally. So what is to the right has come to the left, what is to the left has come to the right, right? And you can have a series of translations, right? So you can have, let's say I'm starting with sine of 5x. I can have a series of translations which leads me to minus sine 10x plus 20 degrees plus 3. I can do a combination of the, or even I'll make it minus 10x. Okay, so not so important, but just so know that by a combination of several of these, one step at a time, translating, shifting, stretching, reflecting, you can get from any function to any other modified function. Okay, so that's the main course for algebra. We still have maybe 2 more minutes. I'm just thinking, maybe I'll just get started a little bit on what you need to know on the number theory part. So see, the main difference between algebra and number theory is, in a way, algebra deals with real numbers. Number theory deals with integers. Otherwise, both are algebra only, if you look at it broadly. Okay, so I'll just paste it here. So squares, cubes, and powers. So I'll tell this usually the same statement, right? So if someone asks you what is 28 square, you'll be able to calculate it's 784. That all of us will do, right? But someone sees a number like, I don't know, 841, right? It should ring a bell that it's 29 square, right? So the reverse process is more important, because in a problem, when you encounter 841, and let's say no one is giving you 29 square, if you're able to recognize it's 29 square, that will give you a hint how to solve the problem. Otherwise, it's a plain blank number. So know all your perfect squares till 1000. There are only 31 of them. 31 square is 961. If you know more than that, that's even better. And there are only 10 cubes less than 1000. those are not less, know them as well. And then powers, right? Powers of 2 and powers of 3 are very important, and learn powers of 2 in buckets of 5. So 2 power 5 is 32. 2 power 10 is 1024. So someone asks what is 2 power 12, you can straight away start counting from here. So it's 2048, 4096, you can say, right? So similarly, powers of 3, at least bare minimum, you should know till 729. So this is 243, and then this is 729. So by the way, 343 is a perfect cube, just 7 cube. 243 is 3 power 5. Don't get confused between the two. I used to get confused, right, quite a lot between these two numbers, 343 and 243, right? Factorization. Okay, so or rather HCF and LCM you can do, right? So if you have any two numbers, or even if you have 3 numbers, right, each of them has some powers of prime numbers. So this is, let's say, 2 power P, 3 power Q, 5 power R, something, right? And this also same thing. The HCF will be the minimum of each of them. So let's say, in fact, I'll put numbers, right? That's easier. So this is, I'll give 3 numbers. So it's 2 power 5 times 3 power 1 times 5 power 7. And this is 2 times 5 square times 11 power 3. And this is 2 cube times 3 square times 7 power 8. The HCF will be the minimum occurrence of each of these prime numbers. So 2 occurs minimum 1 time. 3 occurs minimum 0 times. This guy does not have a 3 at all. So for minimum is 0. So it's 3 power 0, which is effectively 1. And 5 occurs minimum 0 times. Similarly, 7 also does not occur in all the numbers. 11 also does not occur in all the numbers. So the HCF for this simple problem is just 2. Whereas the LCM is the maximum occurrence of each of these numbers. So 2 occurs maximum 5 times. 3 occurs maximum 2 times. 5 occurs 7 times. In the first one, it's 5 power 7. 7 occurs 8 times, and 11 occurs 3 times. So that becomes the LCM. Okay. Okay, all right. Let's pause here. Let's do some more number theory, all of this, and then maybe one more class for sure. Right, I want to revise all of these basic concepts. Right, all of this is known stuff, but I just want to be 100% sure that this basics is solid, and then we can confidently march on to AMC10 problems. Okay, I'll see you next Sunday then. Okay, bye.
Bye.